Hello students, welcome you to this video. In this video I am going to teach the objective questions from differential equations, ordinary differential equations. One of the very simple topic. Let's move on to the first question. The order and degree. So first you must know what is order and what is degree, right? So order means maximum how many times you have differentiated, that is called order. Degree means its power. Maximum how many times you are differentiating, its power, that is called degree. But see that it must be free from all radical sign, right? There should not be any root or cube root. So dy by dx means everywhere dy by dx. There should not be any dx by dy. Some conditions are there. Okay, now look at this. This is the differential equation given in right form, correct form. There is no, yes, radical sign is there, right? Dy by dx raised to 1 by 3 is there. It has an effect of cube root. Suppose a constant raised to some raised to 1 by 3, no problem. So, but here the differential coefficients should be free from all radical signs. So, what we do, take that to the right side. So, d square y by dx square plus x raised to 1 by 4 is equal to dy by dx raised to 1 by 3. So, dy by dx is differential coefficient. It is under radical sign raised to 1 by 3. To avoid that 1 by 3, you have to cube it. But order you can say directly, right? Maximum differentiated 2 times. So the order is 2. So it can be any one of A or C or D, but not B, right? So cubing, so here you get d square y by dx square plus x raised to 1 by 4 the whole cube is equal to dy by dx, right? Because when you cube, the 3 get cancelled. So now it is in right form. So the order, maximum differentiated 2 times, order is 2. Degree means its power. When you expand it, a plus b the whole cube, first term will be a cube, right? D square y by dx square, the whole cube will come. So order is 2 and degree is 3. So the first option is the correct answer. Now listen to the next one. The differential equation representing the family of curves. So y equal to a cos x plus b. So it is not a differential equation. Its corresponding differential equation we have to find. So you have to differentiate. How many times you differentiate? Depends on the number of arbitrary constants. Here what are the arbitrary constants? A and B. So there are 2 arbitrary constants. So you can differentiate 2 times and eliminate that constants, right? So differentiate the first time y1 a into cos x derivative minus sin x. So minus sin x plus b. Inner part derivative 1 only. Second derivative y2 minus a into sin x type, sin x derivative cos x plus b. And here this a cos x plus b can be replaced by y. So you are getting y2 is equal to minus y, bring it to the left side. So y2 plus y equal to 0. y2 means d square y by dx square plus y equals 0. So second option is the correct one. Now question number 3. The order and degree of the differential equation. See, root is there, no need to square because it is under root of sin x only, root of cos x. So no root of dx and all, right? But dx, dy should not be there. So divide every term by dx. So dividing by dx, so you get root sin x. When you divide by dx, 1 plus dy by dx equal to root cos x 1 minus dy by dx, right? So maximum differentiated 1 time and this power is 1. So order is 1, degree also 1. So the correct answer is the third option, 1, 1. Now question number 4. The order means maximum how many times you are differentiating and depends on the number of arbitrary constants. The order of the differential equation of all circles with center, circle with center is h comma k. Center is h comma k and the radius is a units. Then equation of circle is x minus h the whole square plus y minus k the whole square is equal to a square. Here how many arbitrary constants? Please listen here, you have to be very careful. Center is h comma k and radius is a. If they say given radius, that means a is a constant, right? But here nothing they given like that. So h K, A. All the three you consider as arbitrary constants. There are three arbitrary constants, so you take your answer as what? 3. Second option is the correct one. Suppose if they say of radius 1 unit, okay, so then radius is a fixed number, only H and K, right? Or a given radius A, then that is a given value, fixed value. Okay, it won't change. But in this case, they didn't mention anything. The order of the differential equation of all circles with center HK, both varies and radius is a unit. So there are three arbitrary constants. So differentiate 3 times, so the order is 3. Question number 5. Listen. The differential equation of the family of curves y equal to a e raised to x plus b e raised to minus x, where a and b are arbitrary constants. Here they mention, right? Even if it is not mentioned, you know there are two constants a and b, so you are supposed to differentiate 2 times. y1, a into e raised to x derivative e raised to x, plus b into e raised to minus x derivative e raised to minus x into minus 1. That minus will come here. Again y2, a into e raised to x derivative e raised to x minus b into e raised to minus x derivative e raised to minus x into minus 1. That minus become plus. That is y2 is equal to, the right side is exactly same as y. Bring it to the left side. y2 minus y equal to 0. y2 minus y. y2 means d square y by dx square minus y 0. So second option is the correct one. Now question number 6. Listen here. The general solution of the differential equation dy by dx equal to y by x. So dy by dx is equal to y by x. So it is homogeneous, it is variable separable, you can do it in any form, right? So dy by y equal to dx goes up, dx by x. Variable separable, so solution integrate both sides. 1 by y integration log y equal to 1 by x integration log x plus some constant. You write c or even log c, because everywhere in log you can write log c. But the answer, you see, there is no c. They given the constant as what? K. So the constant you take it as what? Log k. So you are getting log y is equal to log kx. Log a plus log b is log of ab, right? So take antilog on both sides or remove log. Y equal to kx you are getting, and that is option number C. Okay, y equal to kx. Now question number 7. The solution of the differential equation 2x dy by dx minus y equal to 3 represents straight lines, circles, parabola, ellipse. So you must know how to identify after getting the equation, right? Straight line means degree of x and y must be 1. Circles x degree 2, y degree 2, coefficients must be equal, in between plus sign should be there, right? Parabola x degree 2, y degree 1, or x degree 1, y degree 2. Ellipse x degree 2, y degree 2, in between plus, and coefficients are different. If the coefficients of x square, y square are equal, it is circles, right? So now let us say, first we have to solve it. By seeing this, if you are thorough with differential equation, all the types will come in your mind. So you can consider this as linear, because if you divide by 2x, dy by dx plus py equal to q, you can consider as a linear. Even variable separable is possible. Please listen. 2x dy by dx is, take this minus y to the right side, so y plus 3. So dy by y plus 3 equal to dx by 2x. dx by 2x. Variable separable solution. Here log of denominator, right? Right, when you integrate, denominator derivative is the numerator, y derivative 1, 3 derivative 0. So log of y plus 3 is equal to 1 by 2 constant, 1 by x integration log x, plus a constant, you say log c. So log y plus 3 equal to log x raised to half root x, right? Plus log c. So that is log of y plus 3 is equal to product rule, log of root x into c. So when you take antilog, you are getting y plus 3 is equal to root x into c. To avoid the root, square it. When you square it, you are getting y plus 3 the whole square equal to root x the whole square is x, right? Into c square is some constancy. Now you see the degree of x is 1. Degree of x is 1 and degree of y is 2. Y square is there, right? So x degree 1, y degree 2 or x degree 2, y degree 1, then you know it represents a parabola. Okay, so C, parabola is the correct answer. Listen the next question. The solution of dy by dx plus py, p is a function of x, that's why they given p of x, equal to 0, q equal to 0, linear equation general form, linear in y, dy by dx plus py equal to q, here q value is 0. So solution is y into e raised to integral p dx equal to integral q into e raised to p dx dx plus c. Q value is 0, so this part fully 0, so you are getting, in the answer you see how they given y equal to, right? So y equal to the c integral 0, 0, leave it c by e raised to integral p dx, take it to the numerator, so you are getting y equal to c e raised to minus integral p dx, 1 by a raised to n, you can write it as a raised to minus n, right? So here your answer is the second option, y equal to c e raised to minus integral p dx. Now let's move on to the 9th question. Listen carefully. Dy by dx, integrating factor of, so it is here to bring it into linear form, right? Dy by dx plus y equal to 1 plus y by x. What you can do, dy by dx plus y equal to split into 2, 1 by x plus y by x. Y terms here to group it. So dy by dx plus y minus y by x equal to 1 by x. So dy by dx plus py, right? Take y outside, you will get 1 minus 1 by x. Only integrating factor they ask, so if I take p value, dy by dx plus py, this is p, 1 minus 1 by x. So integrating factor is e raised to integral p dx. So you are getting e raised to integral 1 minus 1 by x of dx. So that is e raised to integral 1 is x minus 1 by x integration log x. E raised to or a raised to m minus n, a raised to m by a raised to n, right? So you are getting e raised to x by e raised to log x. That is e raised to x by e raised to log x is what? X. Okay, so your answer is e raised to x by x, and that is the second option. That is question number 9. Now let's move on to question number 10. Listen carefully this question. The integrating factor of the differential equation in y is x. Integrating factor given, they asked find p. Normally we know we take p value, we find integrating factor, but here integrating factor is given, right? So integrating factor they given us x. The formula for integrating factor, you know, e raised to integral p dx, right? Equal to x. Take log on both sides. So log e raised to integral p dx equal to log x. Apply power rule, integral p dx into log e value 1, leave it, equal to log x. Differentiate both sides, differentiating with respect to x. Integral and derivative cancel, so you will get p. Are you able to understand? Derivative and integral dx is x. Integral and derivative inverse operations, okay, both vanish, you will get only x. So integrate, when you differentiate differential and that integral cancel, you get only p. So here differentiate log x derivative 1 by x. So this is your answer, option number C. Now question number 11. Listen, before doing this 11th sum, I'll give you the expansion for e raised to x. So we have e raised to x, the expansion is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, etc. In Maclaurin series you would have studied. And remember this is a standard expansion. E raised to x expansion is 1 plus x by 1 factorial plus x square by 2 factorial, etc. So the given function, that is y of x, is exactly of that type. 1 plus dy by dx, that is like our x by 1 factorial is 1, plus dy by dx the whole square divided by 1 into 2. 1 into 2 means 2 factorial only, no? Then next is x cube by 3 factorial, 1 into 2 into 3, same type only. Instead of x we have dy by dx, so e raised to dy by dx. So y of x, it is not y into x, it is y of x, or just you say y equal to e raised to dy by dx. What they asked the question, degree of differential equation. So now e raised to, it should not be like that. So you take log on both sides. taking log on both sides. So log y is equal to dy by dx comes friend, right? Dy by dx into log e, it is 1. So this is a differential equation, maximum differentiated one time and the power also 1, right? So order is 1 and degree also 1. Here they asked find the degree 1. So third option is your answer. Now question number 12, you see P and Q are order and degree. P represent order and Q represent degree of this differential equation. Is it in correct form? Yes, no radical sign, nothing. It is the correct form only. Maximum differentiated 2 times d square by dx square. Order is 2. Degree means its power. Its power is 1 only. So they ask the relation between P and Q, right? So here 2 is greater than 1. 2 is greater than 1. That is P is greater than 1 means it is Q. P greater than Q. Yes, C is the correct answer. So sum number 13. The solution of the differential equation. So dy by dx, take the second term to the right side, equal to minus 1 by root of 1 minus x square. So dy equal to minus 1 by root of 1 minus x square into dx. It is variable separable, right? So you can find the solution now. Solution is integrate both sides, y equal to minus. If you integrate this part, 1 by root of 1 minus x square, it is sine inverse x, right? Plus c, bring it to the left side. Yes. So y plus sine inverse x equal to c. Y plus sine inverse x equal to c. First option is your correct answer. Now the next question, question number 14. The solution of the differential equation dy by dx equal to 2xy. Very simple question. dy, bring that y here, equal to here already 2x is there, dx. Variable separable again. So solution just to integrate both sides. 1 by y integration log y equal to 2 into x integration x square by 2 plus c. 2 cancel. So if you change it into exponential form, y equal to e raised to x square plus c, right? So y equal to split into 2 e raised to x square into e raised to c, right? That e raised to c is a constant. In the application of differential equation, you would have done this. So y equal to c, the constant you take it as c e raised to x square. Y equal to c e raised to x square, and that is option number A. Question number 15. The general solution of the differential equation. So it is given log dy by dx equal to x plus y. Change it in the exponential form, but log of something, right? So you write dy by dx equal to e raised to x plus y. Split into 2. So dy by dx is e raised to x into e raised to y. Now convert it as variable separable. dy by e raised to y equal to e raised to x into dx. Take it to the numerator. E raised to minus y dy equal to e raised to x dx. So which is variable separable. Solution, integrate both sides. E raised to minus y integration e raised to minus y by minus 1 equal to e raised to x plus c. So how they given the answer is e raised to x, e raised to y in same side. So e raised to x, bring this minus here, you will get plus e raised to minus y equal to, take constant to the other side, minus c, minus constant, it is a constant, that's all, right? So B is the correct answer. E raised to x plus e raised to minus y equal to a constant. Question number 16. The solution of dy by dx equal to 2 raised to y minus x. You can write it as 2 raised to y by 2 raised to x, right? A raised to m by a raised to n, a raised to m minus n. Now, dy by 2 raised to y equal to dx goes up by 2 raised to x. Take it to the numerator, 2 raised to minus y dy equal to 2 raised to minus x dx. Again variable separable. Solution, integrate both sides. Integral of a raised to x. A raised to x integration is a raised to x integration is a raised to x by log a, right? So here e raised to minus y integration, 2 raised to minus y integration, 2 raised to minus y by log 2. Don't stop. a raised to x, instead of x we have minus y, so its derivative right in the denominator, minus y derivative minus 1. So a minus has to come. Equal to 2 raised to minus x. 2 raised to minus x by log 2. It is not log x, it is log 2. A raised to x by log a, right? Log 2. Plus some constant. The constant, so here also the minus x is there, no? Its derivative, the minus also you have to write here. Plus a constant. The constant, what I am going to do, some constant. So since we have minus log 2 in the denominator, I am writing minus log 2 into c. Okay, some constant, that's all. So now listen, so I can multiply by minus log 2, so that minus log 2 cancel everywhere. So even if you are not writing here, when you multiply by minus log 2, this minus log 2 cancel, this minus log 2 cancel, you get c into minus log 2. C into minus log 2 is another constant, so take it as c itself, okay? Right, now when you multiply by minus log 2, you are getting 2 raised to minus y equal to 2 raised to minus x plus c. See how they given the answer. Okay, both constant only in the right side, right? So 2 raised to minus x minus 2 raised to minus y equal to minus c, that is a constant. 2 raised to minus x is not there, so bring it to the denominator. 1 by 2 raised to x minus 1 by 2 raised to y equal to c. So the third option is the correct one. Now let's move on to question number 17. Listen to this question. The solution of the differential equation dy by dx equal to y by x plus phi of y by x by phi dash of y by x. But when you see, immediately you may think it is homogeneous. Sorry, yes, it is homogeneous also. It is linear also. dy by dx plus py, right? You bring that y by x to the left side, py equal to q, function of x alone. Also it is homogeneous. Degree, the first term 0, here 1 minus 1, 0. So far x you put tx, y you put ty, there won't be any change, right? So t raised to 1 into, so it is homogeneous of degree degree 0, right? So now you use that method, homogeneous. For homogeneous equation, you know the substitution, we put y equal to vx, and dy by dx is v plus x dv by dx, right? So substitute in the first equation become, instead of dy by dx, v plus x dv by dx, y by x. So here v is equal to y by x, right? So y by x is v. So v plus phi of v by phi dash of v. You can cancel v on both sides. So now you can write in variable separable. So dx by x, this phi dash v by phi of v, right? Upside down into dv. So it is variable separable solution, just integrate both sides. Denominator, derivative is the numerator. So log of denominator, log of phi of v equal to log x plus constant log c. So phi of v is y by x, right? Finally, equal to log cx. So remove log on both sides, you will get this as your answer, and that is option number B. Instead of c, they we used what? K. K is some constant. So instead of c, we use K. So using homogeneous, you can do it very easily. Now sum number 18, listen. If sin x is the integrating factor, dy by dx plus py equal to q, already we did one question, right? Integral factor is x. So e raised to integral p dx is equal to sin x. Taking log on both sides, power rule apply, integral p dx into log e, it is 1 equal to log sin x. Differentiate both sides, differential and integral cancel, so p equal to, when you differentiate, this is of the day log x, 1 by sin x, into sin x derivative cos x by sin x, it is cot x. So the correct answer is cot x, it is not cot c, that also given, right? So be very careful. So the correct answer is B is the correct answer. Question number 19, the number of arbitrary constants in the general solution of order n. Order n means we have differentiated n times. That means number of arbitrary constants is n. N plus 1 means number of arbitrary, if the order is n plus 1, number of arbitrary constant also n plus 1. So your answer is n and n plus 1. If the order is n, number of arbitrary constants also n. If the number of arbitrary constants is n, then you differentiate n times. Normally the order will be n. If the order is n plus 1, then the number of arbitrary constants also n plus 1, right? Then only you differentiate n plus 1. Very direct question. Only the concept of order you must know, right? Now question number 20. The number of arbitrary constants in the particular solution of the differential equation of third order. See, by seeing this third order is 3. So arbitrary constants also must be 3. We may think like that. But this is particular solution. If it is general solution, okay, arbitrary constants will be there. Particular solution, that is a particular one. For arbitrary constants, we give some value. Okay, so you will get, that is called particular solution. Okay, there won't be any arbitrary constant in a particular solution. So there won't be any, what? There is no arbitrary constant means the order is what? Even though the order is 3, differential equation order 3, in particular solution there won't be any arbitrary constants. So number of arbitrary constants will be what? 0 in this case, because particular solution. So I'll give the reason. Particular solution of a differential equation does not contain any arbitrary constants. So that's the reason the answer is what? 0. Question number 21, you see, integrating factor they asked, right? So dy by dx is equal to, denominator is x plus 1, numerator is x plus y plus 1. I am grouping x plus 1 plus y. Split into 2, dy by dx is x plus 1 by x plus 1, 1 plus y by x plus 1, integrating factor. So dy by dx plus py. So minus y by x plus 1 equal to 1. So p value, dy by dx plus py, coefficient of y, minus 1 by x plus 1. Only integrating factor they asked, right? So integrating factor is e raised to integral p minus 1 by x plus 1 dx. So that is e raised to minus log of x plus 1 you will get, right? Apply power rule. So e raised to log x plus 1 raised to minus 1. E raised log something, the something is your answer. So you are getting x plus 1 raised to minus 1. So that is 1 by x plus 1, right? 1 by x plus 1, yes, that's the answer. Now question number 22. The population P in any year T is such that the rate of increase in the rate of change, rate of increase in population is proportional to the population present. So dP by dt is proportional to the population present. When you change the proportional sign, you have to put a constant k. In the answer you see plus k is there, minus k is also there. So whether you give plus k or minus k depends on, if it is increasing you put plus k, if it is decreasing you put minus k. So dP by dt is equal to here increasing, right? So k into p. Now with solution, it's a very simple thing, variable separable, dP by p is equal to k dt, right? So integrate it, log p is equal to kt plus c, change it into exponential form, p equal to e raised to kt plus c, split into 2, e raised to kt into e raised to c. So e raised to c is a constant, so c e raised to kt. C e raised to kt. So the first option is the correct one. Okay, now let's move on to question number 23. P is the amount of certain substance left in after time t. The rate of evaporation, so decreasing, right? Rate of evaporation of the substance is proportional to the amount remaining. So similar question, dP by dt is proportional to P. So but here dP by dt is equal to minus k into P. Hope you understood the reason. Okay, evaporation, so it will decrease, right? So now if you do like the previous question, Same answer but minus kt. P equal to c e raised to minus kt will be your answer. Now question number 24, you see the solution of the differential equation represents a circle. Then the value of a, say not only differential equation results, plus you must know the equation of a circle. What can you say about the conditions of a general second degree equation to represent a circle? What is the general second degree equation? Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals 0 represent a circle. Two conditions. H equals 0. That means there won't be any xy term, right? And the coefficient of x square and coefficient of y square must be same. That is a equal to b. Okay, with this idea we'll try. First to solve it. So cross multiplying 2y plus f. 2y plus f of dy equal to ax plus 3 of dx. Variable separable. Integrated 2 into y integration y square by 2 plus f integration fy. A into x integration x square by 2 plus 3 integration 3x plus some constant. Bring everything to the right side. A x square by 2 minus y square plus 3x minus fy plus c. I am writing in order. This represents a circle since it represents circle. Xy term should not be there. Okay, it is not there. Coefficient of x square. Coefficient of x square must be equal to coefficient of y square. Coefficient of x square is a by 2. Coefficient of y square is minus 1. Cross multiply a equal to minus 2. That is option number 2. Okay. Now the last question you see. The slope means dy by dx. The slope is dy by dx equal to 3x square. They asked to find the curve. So cross multiply dy equal to 3x square dx. Variable separable. Solution integrated. Y equal to 3 into x square integration x cube by 3 plus c. This is your answer. To find c value, they have given a point. What's the point? Minus 1 comma 1. So since it passes through minus 1 comma 1. For x you put 1 and y you put minus 1. So left side y value 1 equal to x value minus 1 cube. It is minus 1 only plus c. So c equal to, bring that minus 1 here, it become plus 1. 1 plus 1 it is 2. So the curve is y equal to x cube plus c value 2, and that is option number A. Hope you understood all these sums. We'll continue the next class.